Okay, now move on to the next section which is interact with contract. So in this section, first we will going to storing messages from users on the blockchain. Storing messages in array using struct. So now we are going to use other data types and save the data on a blockchain. So we have full-fledged web app that can talk to the blockchain. Okay, now if you remember, we want a final app to be placed where people can come, wave to us and send us a message. Also want to show all the past wave messages we have gotten. That's what we'll be doing in this lesson. So at the end of the lesson, we want the user submit message along with their wave, have the data saved somehow on the blockchain, show that our site so anyone can come to see all the people who have waved at us and their messages. Okay. Now let's update our smart contract again. Okay. Let's copy it here and then go through each line. What is big change? Smart contract. Okay, let's go again to our contract folder, web portal, then just paste it and then save it. Okay, so here we have created a struct. Struct is basically a data type where we can hold a group of different data types. Like we have created a wave struct in which we have address, the address of the user who will going to wave, the message the user sent, the timestamp when the user waved. So uh, on the first line we have seen the event, little magic Google what events are in Solidity. So let me explain what events are. Events are basically a function which will which will going to return your front end app some data that what you have just uh, perform on your contract. So we have to create event and then we have to emit it inside the function, and what you want to emit you can write it here. Okay, so basically you will get at your in the front end app. Okay, we'll see it later how we will get it. Then now first see the next line. Okay, here I declare a variable waves that lets me store an array of struct. This is what lets me hold all the waves anyone ever sent to me. So this array will hold complete struct of this wave. So we will just store by each user. So we will have complete list that how many users or which users have just uh, wave to this smart contract. Okay, now just create a function. Okay, it's required of message, so we will going to send a message also. Now the user will able to send a message also, so that's why we are taking a parameter here. Okay, then we are going to push in our array, that is this one array, the complete struct after submitting a values in it. Message that center uh, and block the timestamp are the global variables inside uh, blockchain. You can see my other videos about what are global variables and what are the values of these variables. So here these global variables is message or sender have wallet address of the one who are calling this function, and block timestamp is the current timestamp in Unix timestamp that at which time this block uh, this function is called. And at the end of the line we are emitting this event new wave with the values sender address timestamp and message, so we will get it in the front end. Now we have a function, so this function will return all the waves that we have stored, all the waves array, complete wave array. Here you can write it like that how we can what we want to return it, then we are getting the total waves. Okay, now let's move on. Now let's test it. Copy the content of run.js. Now just script run.js, paste it here. Now let's run it. Okay, so we have to go here and just run this command. Okay, so what is done here? Let's see. The array looks little scary. Yes, it is. Okay, but we can see the data next to the words where message and timestamp is property stored in our message, a message and another message. No timestamp is given back to us as type pick number. We'll learn how to work with it later, but no, there's nothing wrong here. Okay, so we have successfully run it, and it just return our the test that structure complete array that we have called it here total waves. I get all waves, so it just return all the waves inside the array like that. Okay, now so basically whenever we change our smart contract we need to redeploy it. So always be careful whenever you create a smart contract for your live website or your for your to deploy on the mainnet. Try to make sure everything is covered, everything is uh, tested, and everything is working fine before deploying it. Mm, because once you deploy it on your mainnet, then you will never able to change it again. You have to create a new contract and redeploy it, and you will get a new address of that smart contract, and you have to use that new address and that new API file for your front end application. So just uh, always make sure that you will uh, complete your smart contract, and thanks to Ethereum that they have given us a test network which are just simulation of uh, live mainnet. So that's very good for us to test it everything on testnet. Then we will just deploy it on a mainnet. Okay. Now here we need to deploy it again. We need to update the contract address on our front end. We need to update the API file on our front end. People constantly forget to do these three steps when they change their contract. Don't forget that. Okay. Why do we need to do this? Well, it's because smart contracts are immutable. Immutable means it's unchangeable. They can't change. They are permanent. That means changing contract requires a full redeploy. This will also reset all the variables since it's be treated as a brand new contract. So it is very important that you will create a new contract. So all the data that old contract will not be usable anymore. Okay. Uh, you want to use it, then you want to call that old contract. That means we lose all our wave data if we want to update the contract code. Okay. Okay. So let's deploy it again. It is um, whenever we deployable contract is cost us some ether. So it's taking some time to deploy it. Okay, so it's deployed successfully. Now we get a new address. Now what we have to do is to go to the source file and React application app.js and paste it here. And now what we have to do is also copy the new ABI data over here and just open it and just copy it and just paste it. Okay, so now we have updated our smart contract inside the file and API file also inside our front end application. Okay, now let's get all waves. Let's add some other function like get all waves. Okay, okay, let's move these two lines outside the function so we can reuse them here. Yeah, okay, let's see, it's working. Pretty simple and very similar to stuff we have worked on earlier with how we are connecting to the provider, getting the singer and connecting to the contract. I do it by magic here by looping through all our waves and saving them nicely in an array that we use later. Let's see here. Let's see the function get all waves. What get all waves is calling the got get all waves function, which is getting the complete array of a struct. Then we will save it in this variable, and this variable if loop through all the all the data, and then we save it inside this variable here, complete data. Okay, now where do we call this brand new get all waves function though? We'll want to then call it when we know for sure the user has connected the wallet with the authorized account, because we need an authorized account to call it. Hint, we have to call this function somewhere and check if wallet is connected. I leave to you figure out. Remember, we want to call it when we know for sure that we have connected other account. So let's see where we will going to connect it. uh, okay, let's call this function here, that we have showed that we have connected to our wallet, and then we can call this get always function. Okay, now we need to change in front end. Let's see what I'm going to change. uh, okay, let's see what is the error here.